I'm Eleanor Hucker. I'm with Great Lakes Staple Seeds, and we are thankful for the opportunity to share with you today about our SARE Farmer Rancher grant, Predictive Yields for Small-Scale Staple Crop Production. And agenda, I'm going to talk about the first couple things, and then I'm going to let Scott get into the wheat and potatoes of our grant. In brief, before we got a lot of information, I tend to talk fast when I'm nervous, but at the end, this presentation's on our website and you'll have a link on how to get there. Some clarification, we're small scale, so usually anything less than 12 acres. The crops of interest were selected for their nutritional and calorie and functional values. This is only the first year of our 2-year project, and we are in southeast Michigan, about an hour north of Detroit. So these are just examples of some of our crops. We had multiple varieties within each of the different types. We did wheat, we did potatoes, different kinds of barleys. What motivated our project? As Great Lakes Staple Seeds, the second most page accessed on our website is sizing your plot to meet your food needs. And this really became an issue during COVID. People were moving away from casual gardening and really wanted to be intentional of their caloric and nutritional benefits. And also the agronomic data, if you look and you search, a lot of it is for the large scale farms. And nothing against large scale farms, but we want to demonstrate what you can do on a small scale. So our goals is to generate data on actual small scale experience, and that will allow you to better feel comfortable about growing these crops. About me, I am a longtime grower. I love seeds and stories. We spent some time in Asia, and when we came back, I wanted to enrich and enhance my family's homegrown security. Great Lakes Staple Seeds, John Shirk, who presented here a couple of years ago about rice. Any crop that you would want in your larder for a time of national economic crisis. He said that in 2013. He didn't know 2019 and 2020 was coming. All our seeds, we grow 100% on our farm.
I'm Scott, and in high school in 1984, I had to make a decision. I'm very good in math and science. Guidance counselor said I either want to be an aerospace engineer, or I was in 4-H and gardening, grand champion gardening. I could have been the mastermind behind GMO, all that scientific data. But my guidance counselor said, why don't you be an engineer first and then do this as a second career? It'll pay better. He was exactly correct. When we lived in China, that's Shanghai, 26 million people in one city. We knew people when they were kids, they were hungry. At that time, food was rationed. You needed a coupon and you needed money, and then you could eat. And even then, you were still hungry. So that's the motivation. And it all comes down to how much land does it take to feed one person. You see that on memes and blogs on the internet, and you get an answer like 600 square feet. I don't believe it. I think that's if you want a salad as a side dish. So where you live sets up a lot of these challenges. Are you in a river bottom land or in the desert? Next. As she pointed out, these slides were originally prepared for 1 hour, reduced to 60 minutes. This to give you a sense of scale. Big farmers are down here with big equipment. We're in this orange area, 2-wheel tractors, lots and lots of hand tools, lots and lots of exercise. Next. So show of hands. Who has a garden that could be bigger than 32 feet square? Very good. 32 square is 1,000 square feet. It's a metric you're going to see later. Who grows a portion of their dinner? Lots of eating people. Who grinds their own flour? Oh, now we lost a few. We got John only. Who cooks their grain berries? Oh, he picked up a few more. Okay, next. So back to the problem statement. So These are the things that normally keep people from being able to do that, besides your day job. Next. And the key in our mind is that the output of the harvest has to exceed the input of what it took to grow. If you don't grow more calories than you spent farming, you're only going to last until your pantry's empty. So each crop has a different role. In this grant, we were focused on calories, not so much on micronutrients and proteins, but calories themselves. You're going to see some terms later about row width. That's the spacing between rows. And in row, that's the spacing within a row, so like 4 inches between a plant. Because ultimately, to answer the question of how many acres it takes to grow the food, it's all going to turn into what are you getting per square foot. Next. So back in the 120 years ago or so, those people who didn't have much mechanical equipment, they were burning 5,000 calories a day, and they were not worried about losing weight. They were worried about maintaining their weight. So that's because they used their bodies as the machines. So today we have electric motors. They're very handy, and other kinds of engines, but they all take fuel, and fuel takes energy. So in this study, we kept track of the energy it took with a Fitbit, and anytime we used diesel-powered equipment, we kept track of how many teaspoons, milliliters, ounces of diesel we consumed, and we'll explain why a little bit later. And then as we harvested, we weighed the weight of everything. Okay, next. So altogether, we had 13 crop types, like Eleanor showed in the chart. And then, so for example, if we pick barley, there were 89 fall test datas. Some of those are replications of the same variety. A lot of them are different varieties. Different varieties have different purposes and different yielding times. Next. Not everything is threshed and tabulated. There's still work to do in the barn, but spring is coming too fast. So I'm going to show you a bunch of slides just to level everybody up on what we mean by farming, because if you don't see the picture, my grandfather would have been thinking of a 6-row planter, and my uncle would have been thinking of a 20-row planter, and I'm thinking of a hoe. So these are the categories. Next. So soil preparation for us starts out usually by flail mowing the residue from the previous crop, either in the fall. These are amaranth stalks or corn. That'll help small-scale tilling works a lot better if they shred everything up. Next comes tilling. I suppose you could use a broad fork. I have one. For the scale we're on, we're tilling with a diesel-powered 2-wheel tractor. Next. After that, we might power harrow the soil to make a seed bed, and we also raked it by hand, so I know the calorie and fuel differences of these two methods. And planting for us usually involves a wheel hoe. You could use a hoe and make little furrows. That's how we started. It's incredibly slow. It's good exercise, though. This is much faster, and essentially, if you look at old medieval pictures, you see the guy flinging the seeds, or Charles Ingalls. Somehow you have to make those furrows. For us, it's a wheel hoe. You could have pulled something with a tractor, but it's always tough to turn around at the end. And we find in our soil, I can make these furrows about 9 inches apart. I used to measure them. Now I don't. There's no time. But at 9 inches, the furrow makes a mound, and you can make the next mound next to it, and this furrow doesn't fill up the furrow next to it. So that's the constraint on spacing. If you were using a modern drill, you could get closer because you don't have to open a furrow, walk along and sprinkle the seeds. We're nuts on labeling because we're a seed company. Every little orange stick is a different variety. We've switched from little orange sticks to these sticks. They last longer, and they're tall enough to be above the weeds. Long story. Next. There's always thinning involved. This is amaranth, which you can eat as you thin it. Or use your wheel hoe with a scuttle blade and make quick work of the between the rows, and then weed between with a hand tool. We do a lot of that. Potatoes, for us, that means hilling with again a different wheel hoe, but with that little attachment that flips the dirt up. If you only have a 10-foot row of potatoes, yeah, use a hoe or a shovel, but I'll tell you that this is way faster and way less hard on your body. Measured the calories, of course. Next, because it's a science project, lots of data. So you can see some pictures where the tape measure is set out so that we can cut a 10-foot strip from within the plot and then count how many plants there were in a known distance, measure the distance between the rows, and turn everything into square inches to get to square feet, to get to how many acres it takes to feed you. So let's see, we took averages between the rows. That child's not happy. Next. Harvesting for us is not a combine. It's usually a hand sickle like this, or a pocket knife, or scissors. But for this kind of scale, if you were going to grow food to feed yourself, a hand sickle, there's still a lot of part of the world that uses a hand sickle. Be careful. I have cut myself once, pretty badly. Then we make bundles like this, taped and labeled because of the project. And then, you know, like the Amish would stack the stooks out in the field. I'm going to show you pictures. We bring our bundles into the barn so that they can dry in a controlled and protected environment. So here's examples of bundles. You know, this is a bundle of oats, and there's some amaranth waiting to be threshed. This is where it's like on our scale of an acre. We farm about an acre. We got space for probably two or 3 acres of playing this game, and beyond that we would be forced into stacking the stooks outside and taking our chances with the critters. We happen to have this is the slide to say it's best if you and your partners have the same hobbies and interests, because it takes over.
We know that.
Well, you know that.
It takes over your whole house.
Yes.
That too? I didn't show that picture. Next. Threshing involves, so by hanging all those plants in the barn through the late summer and fall, we then can spend all winter in the barn threshing, which might consist of rubbing the seed heads over a screen like this and then winnowing it, which we'll get to, or we have a pedal thresher that can do if you've got larger quantities. This is John Shirk, our mentor. He's beating the grain in a sack, a pillowcase with a rubber hose. That works very well. Next. Winnowing involves carefully pouring the seeds in order to separate the seeds from the chaff, the traditional phrase. So this was we found the best way, and it was a tip given to us in a conference a few years ago. Use shoe boxes because the edge is straight, not a bucket. You get a nice clean edge in front of the window fan, and so then the seeds fall here. Some seeds and chaff fall there, and the really light, fluffy stuff blows out and becomes compost. And so you do have to repeat this several times, and it's a knack. I will admit it's a knack. And always have a tray, because when you're learning, sometimes you'll pour the seeds and they don't go where you thought they would, and you don't want to be sweeping them off the floor. Next. Harvesting for potatoes. Certainly can do it by hand. I did a lot of that as a child growing up. We plant about 500 feet of potato row. That's a lot of potatoes. But so what I found, let me switch to this side, is when digging potatoes, I can dig about 1.1 minutes per foot, which burns about 9 calories per foot if I do it by hand. But if you do it with the tractor, we deleted that video. You can do it way faster, but you do burn some diesel. Well, diesel costs you. So for example, in a 500-foot row of potatoes, we would get 750 pounds of potatoes that represent 167,000 calories. Sounds like a lot, but you got to eat all winter and spring. You might spend 9 hours if you were going to dig all that by hand and burn 4,500 of those calories. But you can do it way faster if you use the tractor. Don't hardly burn any calories, but you burned 1.2 quarts of diesel. And that diesel needs 5 pounds of sunflower seeds, which to make 2.5 pounds of shelled seeds, which would make the oil that you would then make into diesel, which we've read about on the internet but haven't tried ourselves yet. But if you'd eaten those seeds represent 6,500 calories. So nothing's free. Diesel is food, just transformed. So you either, if you got the time to burn your 4,500 calories and dig them by hand. But if you don't have the time, you're going to end up burning more calories, 6,500, because you need to do something in a hurry because you got something else to do. And this is the name of the game in all of the things in this report, but I'm just using this one as an example that nothing is free, time is money, diesel is food for the tractor, which you could have eaten. And of course, this calorie consumption, that's only 4,500 calories to dig the potatoes. No mention of the planting, weeding, hilling, and squashing the potato bugs. So the Fitbit kept track of my calories and my steps. And generally, I can burn either 4,000 or 5,000 calories in a day on a weekend, because I have a day job, or walk 40-some thousand steps. Generally, I can't walk 40,000 steps and work 5,000 calories. I just don't make it. Don't have enough energy. And so these are some daily averages. You can see now my day job does get in the way of all this farming work, but I was burning on average 3,400 calories a day. Make it up by eating it. So, some results. Everything is generally in something per 100 square feet. So be thinking about a 10-foot by 10-foot plot. What are you getting in that 10-foot plot? So this is the first set of data for you, and you can see you get 80 pounds of potatoes. That's what we got per 100 square feet. But potatoes are heavy because they're full of water. And that's why this looks like, oh, you should only eat potatoes. Well, that's been tried before. And you can see the grains down here are way down in the 10 pounds or less because they're dry and they store very well. So this chart is deceiving. It's a trick. So go on to the next slide. So now we need to turn pounds of crops into calories of crops provided by Google. I don't have the equipment to measure that. So these are standardized values from the internet, essentially, to turn all those, this is the same data tabulated and graphed. Next slide. Now we turned all those pounds per 100 square feet into calories per 100 square feet. Potatoes still looks very good, but now it's not as far away from the other grains. And go to the next slide. We'll just rescale that so we can go down and see the grains. And now you can see triticale, which is a kind of hybrid of rye. There's rye, looks about the same, 6,000 calories or so per 100 square feet. Some of them don't yield as much. Buckwheat. How much buckwheat do we eat in our diet today? We do because we grow it, but most people don't. The real winner on this plot is corn. Why do you think corn is in all of our food? Because it's a lot of calories, it's very efficient, and can be made into thousands of things that you may or may not want to eat, but you do anyway. All right, so that raw data in terms of this is going to drive calories per square foot, and there's going to be some combination of grow some of these things. It'll sum up and give you, on average, the 4,000 calories a day that you need 365 days of the year with no safety factor. So we're going to deep dive in barley because that was the first thing we threshed, and that data is all done. So these are all varieties of barley we grew, and so you might wonder, well, what's the difference? Why would you grow different varieties? Some of them you harvest them at different dates. So if you're cutting it with a sickle, you don't want an acre to be ripe in the same day. The birds will get it. It might thunderstorm with hail, or you don't have enough time to cut it all. So different varieties become harvestable in slightly different days to kind of spread the workload out and reduce the risk of total failure, which would result in death. The other difference is some of them have hulls, like this. There's a kind of coating on the seed, and some of them are naked, like this. There's no coating. So we'll get to that later. Next. So all in all, we harvested about 30 pounds of barley that had been planted in the fall, spanning 13 varieties. And this is for us in over between Flint and Detroit. We harvest barley continuously from June 25th through July 9th last year. Every year is a little different, but the key is it's essentially 2.5 weeks of work spread out so that I don't have to take all my vacation at the same time. And we're back to don't put all your eggs in the one basket. And then here's all the barley data in pounds per 100 square feet. And you might wonder, well, why are you getting different yields? Like this guy, he didn't do as good as well as these other ones. And why are the dots all spread apart? And the reason each dot is its own test coupon, it's also, some of them are grown in different fields. Some fields are beautiful loam, others are clay, others are mud. and others are sand, and they all give different values. And in the end, you need to know this. It has to match the fields you have. And so we'll sort all that out. And then the other difference is some of them are hulled and some of them are hullless. That might also be a factor. These are all the other things that could be driving this that we can't talk about today. Next. So here's a close-up view so you can see barley with no hull. This one you can eat right away. I mean, winnow it clean, and it's like 1 part grain, 2 parts water, 20 minutes simmer with a lid on, and then you eat it as like a side dish. Or mush it up and make gruel, very popular in the medieval periods. The hulled barleys tend to be animal feed or malted and then turned into beer or whiskey. So just taking that data and separating it by hulled and hullless, you can see the varieties in terms of weight given. They're not too different. Here's one this Schuler didn't do as well. But there's a story there we don't have time for, historical story. But you're getting about the same pounds. But if you had 6 pounds of hulled barley and 6 pounds of hullless barley, you can eat this immediately. So you need to know what's your use for the grain to decide which one we're going to plant. We get a lot of people planting emmer and einkorn because it's an ancient grain and they read about it or heard about it on the news, but those two grains have a hull. They're very difficult at the home scale to use. They grow wonderfully and most things leave them alone, but then you end up with pounds of grain that you can't eat because I need somebody to invent a home scale cheap dehulling machine. That's my retirement plan. Oh, here's the recipe. 1 part grain, 2 parts water, 20 minutes. All right, next. So take all that weight data and all that calorie data, and this one is in pounds per 100 square feet. All of that barley on the same graph. Now along this bottom axis, this is how many square inches each plant was given. So by changing the spacing in the row, because generally I don't change the spacing between rows, it gets messy. By changing that spacing, I gave each plant, each seed, had a chance to be in a 6 by 10 spot or a 4 by 5 spot. And so in those plots, we then weighed the grains per 100 square feet, and we can see that there's a place where you get more and more grain. You really want to be up here. You want 10 pounds of grain per 100 square feet. You don't want to be down here. And so it looks like something is happening in this 35 square inch area. And if you're this way, you end up with a lot more grain, than maybe twice as much grain as if you had planted with this spacing. But there's a risk, I think. Okay, good. So up in here, it's better yielding, but there's a risk of lodging. You've put the plants so close together, they might fall over. And I've got a picture. Not yet, not yet. So right here, for barley, our research is saying 35 square inches is the magic number. And then we're going to do the same thing for all those other varieties, which we don't have time to show you today. And so your 35 square inches, you could either plant it, 7-inch rows, 5 inches apart, or since I use 9-inch row spacing, I would aim to put one seed every 4 inches. And that would give me my yield in this range of 6 to 8 pounds per 100 square feet, and keeps me away from the edge over here where lodging happens, because lodging looks like this. Now, when the plants are green, when we have this happen, like a storm or planting too closely, done that, sometimes they'll stand back up. But if the lodging happens when it's getting ready to be harvested like this, you've just turned that sickle job into a lot of work to stand it up and cut it and not have the mice climb up and eat the grains. This makes the mice's job so much easier. Next. How many minutes we got left? 5. Okay, perfect. So this, taking all those other slides and turning it into pounds per 100 square feet for different varieties. Next. And then taking all the energy it took in terms of human calories and milliliters of diesel per square foot. Next. This is how we're going to make it fit. And then we assume that, okay, through the season, You don't have to work hard every day. You just have to work hard most days. So I put 4,500 calories in my budget for planting time, harvesting, and more planting. And in the winter when I'm resting, only a 3,000 calorie diet. Add all that up and you get, I need to grow 4,000 calories worth of food a day with no safety factor. Next. Wait, go back. Down arrow. So the internet recommends, 2,000 to 2,400 calories for emergency food purposes. Okay, what that doesn't take into account, growing your own food is not like sitting and reading about it. So to get from, this is your recommended survival food bucket, but if you're going to grow the food to replace what's in the bucket, you need this or more. And let's see, I think some recommended calories per person might be in the 1,200, 1,500 range. Those people are sedentary. They're not working like peasants. Next. All right, putting it all together and just arbitrarily picking some of crops here and combining it all, you end up with this. 26,000 square feet will grow the calories you need for one person. No meat, only grains. And there's a little bit here, the diesel you needed turned into sunflower oil, which means you needed about 3,000 square feet of sunflower to produce the seeds, to produce the oil, to make the diesel, to make this work. But no chickens yet. Also, there's a constraint not yet applied, which I will work on in Excel. You can't plant oats in June, and you can't plant corn in April. Forget the phrase. There's a time and place for everything. There's a season for everything. And so not only do you want to plant all these things, you have to make sure on the day you're planting corn, you actually have enough hours in the day, because you might be harvesting something else or weeding something else. So there's only 30 hours in the day, so you've got to make it all work. Next. If you wanted to add chicken, I did this experiment some number of years ago for fun. We raise our own meat chickens. I needed 4.5 pounds of mixed grains to make 1 pound of chicken meat at the frozen chicken. So that 4.5 pounds of grain represents 7,000 calories. When you got it in the end as meat on the bone in the freezer, there's only 600 calories worth of something to eat. The other 6,000 calories went into the chicken. The life of the chicken lived, the parts of the chicken you didn't eat, the feathers. Now, industrial chicken farms, they do better than this. 4.5 pounds is us. You might be able to get that down to 2 or 2.5 if you're using those chickens that can't walk and you slaughter them the day on the absolute best day. We're kind of slow at that. So if you wanted to add meat to my 3.6 acres, your land use is going to jump fast, because one chicken is needing that many pounds of grain. If you want more than one chicken per year, it goes up proportionally. Next. So in summary, I've explained why this is important for self-sufficiency. We've identified the kinds of work you would need to do, and we showed you the kinds of tools that we think you would use on a homestead scale. We've shown some agronomic data that is what you get with our tools versus a 1,000-acre farm in Iowa using the best hybrid seeds with all the chemicals you'd ever want and equipment that costs millions of dollars. We used barley to show all this relationship between planting density and yield and calories and weight. And in the end, we estimated you need 0.6 acres to feed one person in your family for 1 year with no meat or eggs. That's the last slide. Questions?
Real quick question. On the barley, you had 13 varieties. You planted them all in the fall. Were those all winter barleys, or were some of them facultative?
Some are facultative, but they're ones we tend to grow in the fall planted.
Oh, okay.
There are spring planted varieties in there, but I don't know if they're not in that data set.
Okay.
We get better yield with barley with fall planted.
Okay.
Question in the back?
You mentioned the grants, the word grant came up. How did you fund this? And
Oh.
what was the scale of the grant? What did you use it for?
The grant was about $15,000. It's USDA SARE, S-A-R-E. Their table is in the area where the breakfast is, and If you scan this QR code, you'll get to our report, or you can go to this website and search for presentations. You were going to say?
Well, it's also, you can.
Yeah, Google is your friend. Search that SARE one and you'll find the results.
So that was farmer ranger?
Yes.
Yes.
Farmer
Yep.
Rachel.
Yep.
Yeah.
Other questions? Did you, so one quick question. Did you think it would take 0.6 acres to feed one person? Was that eye-opening, stunning, shocking, or depressing, I guess?
Depressing.
Yeah. That's why when I read those articles that pop up, feed your family on 800 square feet, it's like, no, I don't think so.